Okay, in this video we're going to start with Mergesort. So far we have been doing several sorting algorithms, including bubble sort, insertion sort, and selection sort. All of those algorithms so far have had a time efficiency of n squared, and it's not particularly efficient for a sorting algorithm. For a sorting algorithm, we're trying to find, we like the term log of n log of n, something like that, something with log of n in it, because that's an efficient term. Where have we seen log of n before? When we talk about binary trees. If you traverse a binary tree from the root node to a leaf node, if there are 1,000 nodes in the binary tree, log of n is 10. That's the number of traversals from the root of the node of the tree, the root node of the tree, to the leaf node of the tree, any leaf node. That's 10 traversals. Okay, so if we have a million nodes, then that's 20 traversals. Okay, so the log of n would be 20. Right? If we had 1 billion nodes in the tree, going from a root node to a leaf node is only 30. Okay, so this is the concept behind log of n. All right. The log of n is the height of a binary tree, where n is the number of nodes. So it's essentially the number of traversals from root to leaf. Okay, so if we can use log of n, if we can find some way to insert log of n efficiency into our algorithm, that's going to be a much better algorithm. So these algorithms so far have been n squared. So even if we turn one of those n factors into log of n, so that becomes n log of n, that would be much, much better than n squared efficiency. All right? So Mergesort is the first sort of algorithm that does this. And the reason I bring up the binary trees is be thinking about the binary trees as we create this algorithm. What aspect of this algorithm reminds you of a binary tree? Okay, so with that said, let's take a look and see what Mergesort is. So I've pulled up Tutorials Point, and they have some excellent articles on sorting algorithms and pretty good images here that we can look off of. So the idea of a Mergesort is you start with one big list and you chop it into two pieces, and then each one of those two pieces you chop into two pieces until you get down to lists of either size 1 or 0. Okay, so this is going to be a recursive algorithm. But you see, this kind of reminds us of a sort of tree structure. You have one list, and now you have 2 lists, and then you have 4 lists, and then you have 8 lists. Right? That kind of reminds us of the nodes in a binary tree. Okay, so this might have something to do with our log of n efficiency that we're looking for. Okay, so what we've done here is split this list over and over, and when we're finished, all of these elements are either in a list of size 1 or an empty list. Both of those list types, if it's a list of size 1 or an empty list, are by definition sorted. Right? So if I have a list of just one element, that list has to be sorted because there's only one element. All right? So to actually reassemble all of these lists into a sorted list, what we need is a function that will merge these two lists together. Now the merge is where we decide which element comes first. So if I have 2 lists, all I have to do is compare each item, and whichever one comes first, that goes first in my merged list. So 14 and then 33. Right? So here, 14, 33, 27 and 10, well, the 10 comes first, and then the 27. And then 35 and 19, the 19 comes first, and then 35, and then 42 and 44, the 42 comes first, and then the 44, right? Then we merge these two. So which comes first, 14 or 10? 10 comes first. 14 or 27? 14. 33 or 27? 27. And then there's none left in this list, so we can just, whatever's left on this list, we can just put at the end. Okay, over here, same thing. 19 or 42? 19. 35 or 42? 35. Now there's nothing left in this list. We already know that this list is sorted, right? Because that's what our merge does. It it gives us a sorted list, so we can just put everything that's on this list at the end of our merged list. Okay, and then we go down here and we merge these two lists together. Now keep in mind, when we use this merge, we're going to make a function called merge. It takes two lists that are supposed to be sorted. So it can just look at the first item of each list and compare and see which one to add to the merged list. So 10 and 19, we've got 10. 14 and 19, 14. 27 and 19, 19. 27 and 35, 27. 33 and 35, 33. So now this list is empty, so everything that's left in this list can just be attached right here. And the result is an ordered list. Okay, so that's the concept. So we divide the list in half and sort each half, divide the list in half again, right? Until we end up with a list with one element in it, or none. Okay, so let's start with this in Python. Okay, so our other sorting algorithms, we're making use of a swap function. So merge does not make use of the swap function. Instead, we have a merge function. And merge is going to take two lists, A and B. Right? And we're going to have a value, an index value starting at I equals 0. And this is going to be the index value of A. And then we'll have an index value of J equal to 0. And that's going to be the index value of B. So basically what we're going to be doing is, like we did down here, we have one list A and another list B. And the index we're comparing is 0, so that's I for list A, and J is 0 for list B. And as soon as we find one to go in our merged list, then we increment our index. So we see that the item, that the ith index of A is 10, and that's the least out of, when you compare it to the jth item of B. Right? So 10 is less than 19, so 10 goes down here, and we increment the I index. So now the ith item of A is 14, and the jth item of B is 19. Which one's less? 14. Right? And then we increment I because we, right? So this is how we're going to be, we need to set up some mechanism, some helper function that lets us merge basically two lists that are sorted. The idea is these two lists would be sorted. Okay, and we're going to end up with some merged list. All right, so we're going to loop essentially while let's see, while I, which is the index of our A list, while I is less than the length of A, and B is less than the length. I'm sorry, J is less than the length of B. Okay, so this is our loop. This is saying as long as the index I is less than the length of our list, then I is a valid index for the list. If I ever becomes the length of this list, then I is no longer a valid index. I can't access the ith index of A because I is outside the bounds. Okay, so this is just saying as long as I is inside the bounds of A, and as long as J is inside the bounds of B, then we're going to do this. Now when we get finished, one of these is going to be false. The other one will still be true. So that means one of these lists is still going to have items in it. We saw that here. All of these items went in. See, we got 33 in here, and then we still had 35, 42, and 44. So then all of these items, that would be J was still less than B. This is still true. Okay, so after this while loop, we're still going to have to check to see which one of these is true, and then add all of the rest of the elements from either list A or list B into our merged list. Okay, so this condition is only true as long as I is a valid index for A and J is a valid index for B. So if that's true, then we want to see which one is smaller. Is the ith index of A less than the jth index of B, right? So if the item in A is smaller, then we append A sub I. And then we increment I, because we added that item, right? So we need to add 1 to I. Otherwise, so this was the case that A sub I is bigger than B sub j, right? Otherwise, that means B sub j is bigger or equal to, right? In that case, we'll add B. Sub j. Then, if we're adding from the item in B, or adding from the list B, then that means we have to increase or increment our j index by 1. All right. And so this is going to basically do what we did here. It's going to compare these two items, 10 and 19, find 1, and then increment I, compare, find 1, and then increment the appropriate item to 27, compare, find 1, we found 19, increment j this time, and then 27 and 35, right? 27 comes down, increment, and then 33 comes down, and at this point, this condition is false. We've incremented I one last time, and I is 4. 4 is not less than the length of our list. 4 is not less than 4. 4 is equal to 4, but it's not less than 4. So this part of the condition fails. So this is false. The only way the whole condition is true is if both of these conditions is true. Okay, so this condition is false, which means we break out of the loop. But that also means that this condition was still true, meaning we still had items in our B list. So we want to go ahead and add all of those items into our list. But we don't know, in our example we know, but in code we don't know which one of these two conditions failed. All right, it could be either I is less than the length of A, it could be that failed, or it could be that J is less than the length of B. It could be that condition failed. So we have to check down here. So we've broken out of the while loop, and we're going to check. And what are we going to check for it? If I is less than the length of A, then that means I is still a valid index for A. Once I becomes the length of A, then I is no longer a valid index, right? So this is just saying if I is still a valid index of A, then it must have been this other condition that broke, which means that there's still items in A we need to add to our merged list. Okay, so if I is still a valid index of A, then we need to make a for loop for k in range, and we'll start at I and go to the length of A. Okay, so k is going to be a new index value. It's going to start wherever I was, wherever I left off, because I was still a valid index for our list, and then it'll go all the way to 1 minus the length of A, as the range function does. All right, so k now, basically in this loop, we just say merged, our merged list dot append, and we're going to keep merging from our list A, the item k. So k is going to be the remaining index values. All right? So that's if I is still a valid index for B. If it's not, then that means J has to be still a valid index for B. Okay, so in that case, we do something similar. We make a for loop for k in range, but instead of I to length of A, we say J to length of B. Okay, so J was the index here. J was 35, so that's index 0, 1, right? So J was index 1. 1 is less than or is less than the length of b, which is 4 in this example, right? 1 is less than 4, so that means k is going to become 1, and length of b is 4, so that range is going to generate a list 1, 2, and 3. So k is going to become 1, 2, and 3, which are all valid indices for our list b. And then we say merged.append a list b, and we're accessing item k. Now take some time with this. Pause and really make sure you understand what's happening here. It can get a little confusing with all of the subscripts, all of the indices being accessed, okay? But J is meant to be the index of list B, and I is meant to be index of list A. All right, so make sure you understand what's happening here. It's simple but complicated at the same time. All right. So here what we're going to do is we're going to return, after all of this, we're going to return merged. And that's going to be our merged list. So this is our helper function. This merge function is basically performing these tasks. If we have these separate lists, merged will, if we have 2 ordered lists that we give it, it will result in 1 ordered list made up of those components, right? So 2 ordered lists, and then 1 list is returned with them, all the elements joined together. 2 separate ordered lists joined. Separate ordered lists joined. Here, same thing. 2 ordered lists. Both these lists are in order, and it returns an ordered list. Okay, so that's what this merge helper function does. Now, before we go any farther, we need to test this out and make sure it's working. Okay, so we're gonna be testing out this merge function. So let's go down to the bottom of our script here, and we're gonna print out a few merge calls. Okay, so we're supposed to give it 2 lists. Okay, let's see what happens if we give it 2 empty lists. We would assume that we'd get an empty list back. Let's see what happens when we give it a list with 1 element, and then the other list has just 1 element, and then we have 2 elements, and then we have something like that, and then we'll have something like that, and then something like that. So that should be pretty good. So the first one, merging 2 empty lists, should be the empty list. Merging 1 list with 1 sorted value and 1 list empty should just be a list of 1. Same here, list of 1. This should be list 1 and 2. Right? This should be 1, 2, and 3. 1, 2, and 3. So we're trying all the different ways that this could go wrong. So we can do a couple more. 3, 4, 5. And here this would be 3. All right. So we'll try these out and see what we have. Plus X, merge, merge.py, and what are the numbers we want to use? We'll start with these. It doesn't really even matter though, because we're just testing out our merge functionality. So the first one, empty list, that looks good. Then we have 1 and 1. That's these 2. That looks good. Then we have 1, 2. That looks good. We should have 1, 2, 3, 1, 2, 3. That looks good. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so this looks like our merge function is working properly. Okay, so that's good. You can comment that out or delete it. All right. So merge is working, and now what we need to do is make merge sort. So my sort in all of the examples we've done so far is the sorting algorithm we've been working on. So in this case, this is merge.py, so this is actually the merge sort algorithm.